Hello community. Here you see what is the program of this particular video. We're going to download a BERT model from Hugging Face. We will build our own sentence transformer from scratch with different layers. And finally, I will train this sentence transformer with my personal training dataset. And I will show you that there is a special loss function where you can improve the performance of your sentence transformer, your SBERT model. So let's jump right into it. We're working on a free Colab notebook. This means we have to install our sentence transformers, our PyTorch, and we activate our CUDA course. Of course, we have to download some libraries from the sentence transformers and some gzip and some pandas and numpy, all the typical candidates you already know. So let's start with the first point, download a pre-trained BERT model. Now, a lot of people ask me about pre-trained, so let's have a look at this. If you download a transformer model, let's say distill Europa base, please check in the description of this transformer model that this model has been trained. And distill Roberta was pre-trained on an open web text corpus, about 13 GB of compressed file information. The model is the small Roberta model, has 6 layers, 768 dimensions, and 12 heads. The nice thing is it is twice as fast as Roberta base model. Now, if you look at Roberta base now as a transformer model and you would like to build your sentence transformer based on Roberta, you have to know that Roberta itself was pre-trained on 5 datasets. This includes English Wikipedia and some articles between September 2016, February 2019, and in total you have about 160 gigabytes of text. Now, the pre-processing of this text was, of course, tokenization. We're talking about BERT, so we have here a byte version of the byte pair encoding. I have a specific video on BPE, and the vocabulary size should not be below 50K. And then the pre-training, of course, was done professionally on 1000 GPUs. So this is the great thing. We download these models, and you can see I go for the small distilled Roberta model. I say the maximum sequence length of my sentence will be 128 tokens, not words. The number of epochs, just for demonstration purpose, will be 1. And my training batch size, since we are running here on a free Colab, is 16. Please increase it to 32, 64, given your resources. So, and now we define our sentence transformer model, layer by layer. The first is our word embedding. Our word embedding model is our transformer we just defined with a maximum sequence length. And then we need to get a fixed sentence vector so that all the sentences which have 2, 3, 5, 12, 23 words all have the same fixed size output size. And our sentence vector will be a 768 dimensional vector, which will create a vector space. So this means we have a pooling layer or a pooling module where we start with our word embedding model and we get the word embedding dimension and we define a pooling mode. Here we go for mean, but you can choose max or normalized. Whatever suits best for your task, please choose accordingly. And then we define our model, and this is the line where we do this. We say we want to build a sentence transformer model, and we have 2 modules. We have our word embedding model, and we have our pooling layer. Please feel free to add other layers, like feed-forward layers, dense layers, or whatever, given the task that you are doing. We will define a path to save our model later so we can revisit and reuse our trained model. Now, the next step, let's go back to the graphic that we have defined now here, our pooling layer and our Hugging Face BERT model is now to download the training data set and start training it with a special loss function. Let's do this. So here we go. Oh, I have to connect to my Go drive. And here we are back, and I just downloaded my gzip file from my training data from my Google Drive. So let's now create our training data set, the data loader, and the data elements. We have now a dataset path. This is where my gzip file rests. And I say, okay, let's have with a CSV dict reader, let's just do the training samples, let's do the test samples, and let's do the development samples. And this is easy, straightforward, and you define your data loader with your shuffle and your specific training batch size. Let's run through this. Oops, we got an error, train batch size is not defined. Yes, of course, because I forgot to execute this cell. Oh, great. And I did not even execute the next one. As you can see here, when we download the transformer model, this is my distilled Roberta base model, you see that you download 316 megabyte of data. This is the pre-trained distilled Roberta base model that has already been trained on some corpus, some English corpus. So, but now it's time to set up our data loader. And then we just print out the size of my personal data set that you see the dimensions I would recommend. So I have 200,000 sentence pairs, and I go with an SNLI morphology. So I have, as I will show you here, I have the labels. I have 3 labels: contradiction, entailment, and neutral. So the standard SNLI dataset that you know and you are familiar with. So having 200,000 sentence pairs with labeled data. If you want to have a look at this, yes, I always check visually because you never know. You see, this is what we have. This is my training data set. My sentence 1, and then a lot of sentences 2, given a sentence 1, where I have entailment, where later on you will see I have some contradiction and neutral. And here you have, this is split into training data set, and then the development data set, and the test data set. If you just have an explorative data analysis, you can see that I have only 14,000 unique sentences 1 and only 50,000 unique sentences 2. I have 3 labels and I have 3 training data sets split. And this gives you a good overview, even if you have 200,000 sentences, because you need the combinatorial power of those 2 sentences in a sentence pair. Be aware that you should maybe increase the number of unique and therefore increase the amount of sentence pairs you will train your system on. Now, you would go on, and now we are here. Let's go back to the graphic. We have done the training data set. We have defined here our sentence transformer, our SBERT model. And now you would say, hey, let's go with a cosine similarity loss function. But today we go for something special. And this special is a little bit more complicated, of course, but it yields a better performance. So normally we would do losses from SBERT cosine similarity. What we do is multiple negatives ranking loss function. If you want to see this, well, of course, here we have an API. And as you can see, it's a class multiple negative loss. And I leave you the link in the description and you can check out the methodology. It is quite some interesting code, and especially if we now have to prepare the data loader for this particular loss function. So I have here my dataset path where I have my training dataset now to train this SBERT model on this particular loss function. And in order to be able to do so, we have to do something. So again, we have the CSV dict reader. So we here split sentences 1, sentences 2. And then we have defined a function add to samples, where you see that you're operating now on a set operator for contradiction, entailment, and neutral. Now let's execute this code. And then we go on and we want to define, as you can see here in our train samples that we defined here, we take those and we say, okay, let's have sentence 1 and all the other sentence. And if you read in the description of, where is it? Here, our multiple negatives ranking loss function, you see that we need triplets. And our triplets is simple. If you say sentence A1, a sentence B1, and a sentence C1, where A1, if you want, is something like your anchor sentence, C1 is something like your contradiction to this, and B1, you can think of your entailment sentence, if you think about an SNLI dataset morphology. So we have defined our hard negatives, and this will improve our performance, hopefully. So here we go. We say if the others, we have an entailment and we have a contradiction, then we just say, okay, take sentence 1, take a random choice of the entailment sentence and a random choice of a contradiction sentence. And then you just take a random choice entailment, then sentence 1, and then the contradiction. This is a special format for our specific loss, the multiple negatives ranking loss. So we define here our train data loader, and there's a specific data set in SBERT that you say no duplicates data loader from your training batch size, your train samples, and your loss model. We define this, and now we're ready to train our model. If you want now, during the training run of your SBERT model, to have an evaluator while the system is training, that you can see the progress, you can now download a different benchmark data set. Here it is the STS benchmark data set. So we just download it. It's available for you at this link. And then to do absolutely the same, you see CSV dict reader, and you say, please now go for the development split of my training data set and just append everything together so I get an embedding similarity evaluator from my input samples of my development samples. So completely different from my training set. We just read in the STS benchmark dataset, the official benchmark dataset, and use this dataset as an in-training evaluator. Do not mix up, please, the training datasets. And then finally, we are able to do this. Yeah, we have to do this. Download the dataset. And you see my development samples from STS benchmark. There are 1,500 sentence pairs. Okay, and finally, we come now that we can fine-tune our SBERT model with our specific individual training dataset, where we have chosen a domain-specific knowledge. Now, the number of epoch, whatever you have, some warm-up step, but here is the main code. And here we train now our SBERT model with our specific dataset, with our train data loader, and our specific loss function that I just showed you. We have as an evaluator during training the STS benchmark dataset, the development set, the number of epochs. You have evaluation steps. I go with half. Some warm-up steps. You say save the best model in this specific path we defined. This is it. And you start the training of this model. As I think that I did not activate my GPU, let's have a look. I'm running on, I have no hardware accelerator, great. So I'm not gonna wait because this is gonna take 6 hours on a CPU. That just takes 20 minutes on a GPU in Colab. But I think you get it, exactly. You just run it and you get a model that has been trained on your individual training data set with a great loss function that should improve the overall performance. You have, during the run, an inside evaluator. But please watch out, because if you have a personal training data set that has another domain, let's say my training data set is on physics only, And now I don't know how many sentences on physics, mathematics, chemistry, material science is within this SDS benchmark dataset. So it's always best to look for domain overlap. And if you take these official benchmark datasets and you have a very, very specific, domain-specific, high-energy physics training dataset, well, of course, if you compare physics to a general benchmark, you will have not the optimal performance if you use a personal training dataset that is about news, about politics, about economy, everything you find in the newspapers or on your news feed, then of course you will have a better performance. So the system is running. This is great. I think we can forget about this. We're not going to wait 7 hours. And then we have a fine-tuned SBERT model. And you know that you can already also download from Hugging Face a pre-trained and fine-tuned SBERT model. You have this with model equals sentence transformer. And then you have here in the first characters defined the data set that this has been fine-tuned on. So remember, the still Roberta has been pre-trained on something as a transformer model. And then this whole pre-trained model with the tokenization and with the, I don't know, 1000 GPU cluster has been trained. Then it has been fine-tuned here on the SNLI training dataset. And now, since I did more or less the same, only instead of the official SNLI dataset, I used my specific training dataset. You see that I get now a model that I can save as my SBERT model on the domain high energy physics, or you have maybe domain medicine or domain law or the domain marketing or whatever you have. I have now a sentence transformer model trained on my specific training dataset. Yes, my training dataset on the model Roberta, if you have Roberta or distill Roberta, and the base model. Of course, if you have more compute resources, you go with the bigger models, the higher performance model, but this is just for demonstration purposes. So we have achieved our task. We have our trained SBERT model on our individual training datasets. Great. And now we can use this SBERT model to encode a new text corpus and do some cosine similarity visualization to see, for example, the task could be clustering, or you have semantic search, whatever. We have now a specific fine-tuned sentence transformer SBERT model that has been fine-tuned on your individual training dataset. Now, of course, if you saved it, as you see here, say output path is model save path, it is saved somewhere. I don't think we will have an output here. No, not yet. But you would have here then an output directory and all the model files, the model parameters included, but of course only when it's finished. And you can then re-upload or upload your sentence transformer model if you save this directory in your cloud, or you transfer it to your Google Drive or whatever, you download it on your local disk, whatever. And then if you really are interested, you can choose now for the whole system another benchmark. You can say, okay, I want to have an evaluation of the model. Now that the complete model has been trained, you can also train now the complete model on this. So you need another data set. And now, just for a simple reason, we take here now the test part of the SDS benchmark data set, the official data set. Here before we had the development training data set, and now we take the test data set. And what we do is we say simply, let's define a test evaluator of the model, embedding similarity evaluator from input samples. And now we take as the golden standard, if you want, the test samples. Test samples we had downloaded again as the benchmark data set. And we say, hey, we just want to have the test data set within. Then you can evaluate your SBERT model independently after training if you have a specific data set. Let's say you have a second personal data set. Your first could be, I don't know, chemistry, and your second could be medicine. And you want to have now an evaluation how good your SBERT model trained on chemistry evaluates against your data set that you have on medicine. This is exactly the way to do it. And this is it. We achieved everything that we set out to do. We arrived at the end. I hope you enjoyed it. I will leave you a link to this specific Jupyter lab in the description of this video, and I see you in the next one.